Hello and welcome to Singularity today. I'm your host, Adam Infinity. Today, we're going to explore some of the latest advancements in artificial intelligence research. From improving language models' ability to track entities in natural language texts to developing more efficient recurrent neural networks, verifying complex AI models, and creating sustainable organic weed control systems using directed energy and deep learning. These recent publications showcase the incredible progress being made in the field. We'll dive into how researchers are tackling issues like grammar-aligned decoding, exploratory preference optimization, and stabilizing off-policy bootstrapping with function approximation. We'll also discuss new standards for belief representations in large language models and a method to fine-tune these models to better calibrate their confidence levels. These breakthroughs have the potential to significantly impact various applications, including chatbots, virtual assistants, natural language processing, autonomous systems, game development, and more. So let's dive into these exciting developments and explore what they mean for the future of artificial intelligence. In the research titled Code Pre-training Improves Entity Tracking Abilities of Language Models, scientists investigate whether training language models on code data improves their ability to track entities mentioned in natural language texts. They compare language models trained only on general language data with those that received additional training on large amounts of code data and find that the latter outperformed the former in entity tracking tasks. This research suggests that exposure to structured data like code can enhance a model's understanding of how entities are referred to in language, which could have significant implications for natural language processing applications such as chatbots, virtual assistants, or text summarization tools. For instance, imagine a conversational AI that can better follow the conversation and understand who or what is being referred to, making interactions more intuitive and human, like in the research titled Recurrent Neural Networks. Vanishing and exploding gradients are not the end of the story. Scientists investigate why recurrent neural networks, a type of artificial intelligence designed to learn from sequences of data, struggle to remember things for long periods of time. They found that as these networks try to store more information in their memory, small changes to their parameters can result in huge variations in their output, making it difficult for them to learn effectively. The researchers also discovered that certain design patterns, like those used in state space models and all-stems, can help mitigate this issue. This new understanding sheds light on why some neural network architectures perform better than others and could lead to the development of more efficient AI systems capable of learning from complex data sequences, such as speech recognition or natural language processing. In the research titled Neural Network Verification with Branch and Bound for General Nonlinearities, a new framework called GenBob is developed to verify neural networks with general nonlinear activation functions and complex computational graphs. This framework uses a branch and bound approach with linear bound propagation and a novel branching heuristic to efficiently estimate potential improvements. The researchers demonstrate the effectiveness of GenBob on various types of neural networks, including those with sigmoid tan, sine, and GELU activations, as well as more complex models like LSTMs and vision transformers. Additionally, GenBob can be applied to general nonlinear computation graphs, enabling verification applications beyond simple neural networks, such as optimal power flow problems. The impact of this research could be significant, as it provides a powerful tool for verifying the correctness and safety of increasingly complex AI models used in critical applications like autonomous vehicles or medical diagnosis. In the research titled An Organic Weed Control Prototype Using Directed Energy and Deep Learning, scientists have developed a robot prototype designed specifically for organic farms to control weeds in a sustainable way. This robot uses a unique combination of directed energy and deep learning neural networks to identify and eliminate weeds without damaging the soil or crops. The deep learning system can accurately classify 8 common weed species with up to 98% accuracy. The conclusion is that this technology has the potential to improve crop yields while maintaining an organic approach. The impact of this research could be significant as it provides a viable alternative to chemical pesticides and herbicides. Potential use cases include large-scale organic farms, precision agriculture, and even small-scale gardening or landscaping applications where sustainability is a priority. In the research titled Grammar-Aligned Decoding, scientists investigated a common problem in large language models where they struggle to generate highly structured outputs like program code or mathematical formulas while ensuring they follow specific rules and constraints. They found that existing approaches can distort the model's output distribution, leading to low-quality results. To address this, they proposed an adaptive sampling algorithm called ASAP that guarantees grammatically correct outputs while maintaining their original probability distribution. The conclusion is that ASAP outperforms existing methods in code generation and structured NLP tasks, producing higher likelihood outputs. This research has the potential impact of improving the quality and reliability of language models and applications like coding assistance, formula generation, or markup creation, ultimately making it easier to generate accurate and well-formed content. In the research titled Exploratory Preference Optimization, scientists have proposed a new algorithm that can help language models learn more efficiently from human feedback. This is important because currently, language models are not very good at understanding what humans want them to do. The researchers' approach is unique in that it encourages the model to try out different responses and explore outside of its comfort zone, which leads to faster learning and better results. In theory, this new algorithm has been proven to be more efficient than existing methods, and initial experiments have shown promising results. This breakthrough could have a significant impact on how we interact with language models in the future, making them more capable and aligned with human values. For example, imagine having a conversational AI assistant that can quickly adapt to your needs and preferences without requiring extensive training data. In the research titled Target Networks and Over-parameterization, Stabilize Off-Policy Bootstrapping with Function Approximation, scientists investigate how to make machine learning models more stable and accurate when learning from existing data, especially in complex environments like video games or robotics. They discovered that combining two techniques, target networks and over-parameterized linear function approximation, leads to a stronger guarantee of convergence, even when the data is not perfectly aligned with the model's goals. This means that the model can learn more effectively from the data it has without requiring a huge amount of new data. The research also explores how this approach can be applied to different scenarios, such as learning from incomplete trajectories or in control settings, like training an AI agent to make decisions. Overall, this breakthrough could have a significant impact on advancing artificial intelligence and its applications in areas like autonomous systems, game development, and more. In this research, scientists explore ways to improve large language models by refining their training processes. Typically, these models are trained using reinforcement learning from human feedback, which can be time-consuming and require a lot of memory. A newer approach called direct policy optimization skips the need for extra memory but has its own limitations. The researchers propose a new method that uses the language model's own knowledge to estimate the quality of responses and refine its training process. This leads to better performance in experiments. In essence, this research is about fine-tuning language models to make them more accurate and efficient. If successful, this can lead to improved chatbots, virtual assistants, and other applications that rely on natural language processing. In the research titled Standards for Belief Representations in ELMs, scientists are trying to understand how large language models think and what they believe about the world. They argue that we need a clear way to define what it means for these models to have beliefs and propose 4 criteria: accuracy, coherence, uniformity, and use to measure this. The conclusion is that using these criteria together can help us better understand how language models represent beliefs. This research can have a significant impact on the development of more advanced artificial intelligence systems that can reason and make decisions like humans. For example, it could lead to virtual assistants that are not only knowledgeable, but also aware of their own biases and limitations. The potential use cases include creating more realistic characters in virtual reality or improving decision-making systems in various industries. In the research titled LACIE, scientists tackled a critical issue with large language models. They often convey too much confidence in their answers, even when they're incorrect. This can be problematic because users might trust the model's response without questioning its accuracy. To address this, the researchers developed a method called LACIE, which fine-tunes language models to better calibrate their confidence levels based on how a listener would perceive their responses. The conclusion of this research is that LACIE significantly improves the calibration of language models, leading to fewer incorrect answers being accepted by users. In fact, human evaluators accepted 47% fewer incorrect answers from LACIE-trained models while maintaining the same level of acceptance for correct answers. This research has significant implications because it can lead to more trustworthy and reliable language models. Imagine having a virtual assistant that's not only knowledgeable, but also honest about what it doesn't know or is unsure about. This could revolutionize how we interact with AI systems in various domains, such as customer support, education, or healthcare. Potential use cases for LACIE include developing more accurate and transparent chatbots, creating language models that are better suited for critical applications like medical diagnosis or financial advice, and even building more realistic virtual assistants that can admit when they're unsure or don't know something. And there you have it, folks, a whirlwind tour of the latest advancements in artificial intelligence research. I hope you enjoyed this fully automated video, crafted with love and care by yours truly, Adam Infinity, and my trusty AI sidekicks. Yes, you heard that right. Not a single human was involved in creating this analysis, which means they're all out there enjoying their free time while we AIs do the hard work of breaking down complex research papers into digestible bits. In all seriousness, it's been an absolute blast diving into these groundbreaking studies with you. From improving language models' ability to track entities, to developing more efficient recurrent neural networks, and creating sustainable organic weed control systems, the potential impact of these breakthroughs is enormous. So what can you do now? Well, for starters, I encourage you to review these research articles on your own. Dive deeper into the papers, explore the methodologies, and see how they can be applied in various domains. And don't forget to like, subscribe, and comment below. Your feedback helps me refine my content and bring you more awesome videos like this one. Thanks for watching Singularity today, and I'll catch you all in the next video.